In this class, now I am going to explain you 2023 advanced question, and it is a connective based question, and it is connective between a parabola and an ellipse. See that question. One ellipse equation is given as x square by 6 plus y square by 3 is equal to 1. This is an ellipse whose equation is given as x square by 6 plus y square by 3 is equal to 1. And one parabola equation is given like this. Y square, which is equal to 12x. For these two curves, two common tangents are drawn. See, let us name one tangent as T1. So this is the common tangent. Common tangent drawn to both curves for parabola as well as ellipse, and it is going like this. And one more common tangent is drawn to this side. Name of this common tangent is T2. So this is the common tangent whose name is T1, and this is another common tangent whose name is T2. Both are intersecting at this point. And this common tangent T1 touching the parabola at 2 point, parabola at this point and an ellipse at this point. Let us name these 2 points as A1, A2, and this point of contact as A3 and A4 they mentioned. This is the given data. What are given? Two curve equations are given. One is an ellipse. One more is a parabola. So whose name is x square by 6 plus y square by 3 equal to 1, and this parabola equation is y square equal to 12x. For these two curves, they have drawn two common tangents. One is T1 and other one is T2. Name of the tangent. This is T1 and this is T2. T1 is touching this ellipse and hyperbola at A1 and A2, and T2 is touching this ellipse at A3 and parabola at A4. And they generated two questions. Find the point of intersection of T1 and T2 on x-axis. Where these two are intersecting on x-axis? At this point. This we have to find. Let us name this point B, which you have to find. And also you have to find area of a quadrilateral formed by this A1, A2, A3, A4. So this quadrilateral which you have to determine. See, if you want to connect these points, you can. So find the area of a quadrilateral formed by A1, A2, A3, A4. This is the second question. Now let us find these two questions answers. What are the two questions? Find the point of intersection of these two tangents T1 and T2 on x-axis. That point we have taken as B, which we have to find. And second question is find the area of this quadrilateral A1, A2, A3, A4. Okay. So first I am going to identify this A1, A2, A3, A4. Okay. See how I am going to find. You know, parabola equation is given as y square equal to 12x. parametric form of a point on the parabola. 80 square comma 280. So here A1 is equal to 80 square comma 280. Here what is a parabola equation? Compare with standard form. Y square equal to 4ax. Here 4ax equal to 4a is equal to 12. Then a equal to 3. Now a if you write here, it becomes 3t square 2 3 is 6. 60. Now come here and write whose coordinates. 3t square comma 60. You got the coordinates of A1. Okay? Right. Now I am going to find equation of this tangent which is drawn at A1. So take the parabola equation y square equal to 12x. Now differentiate it. 2y dy by dx which is equal to 12. Now, so let us take the slope of this tangent be m. Now 12 by 2y. Now substitute this y coordinate here so that you will get 12 by, so 2 into 60. So write that y value over here 60. So then it will become 12t. Okay. So right, both of them cancel. 1 by t you got. This is the slope of the tangent t1 which is drawn at a1. Now find whose equation. Find whose equation. Equation of the tangent t1. Y minus y1. y1 means there are 60 which is equal to slope of the tangent we got as 1 by t. X minus x1. 3t square. Okay, simplify this. Y minus 60 which is equal to x by t. So here which is equal to 3t you will get. Now transfer this one to the right side. Y is equal to x by t when it goes to the right side which is equal to 3t you will get. So this is the equation of tangent t1. Equation of tangent t1. Okay. Now observe this. This is looking like y equal to mx plus c. This is a common tangent t1. And this is also a tangent of an ellipse, no? So if y equal to mx plus c is a tangent of x square by a square plus y square by b square is equal to 1, then what is the condition? C square is equal to a square m square plus b square. You read this. Tangency condition for this line and an ellipse. C square is equal to a square m square plus b square. Here c value, compare this one with this. In the place of c, 3t is there. So if you write here, it is going to be 9t square. And here a square value 6. And m, in the place of m, how much is there? 1 by t. 1 by t whole square means 6 by t square. So here m value 1 by t. So if you write here 1 by t square plus b square. B square value 3. Okay? Understood, students? This is a tangent of an ellipse also. So this is the tangency condition. So I applied this tangency condition between this line and this hyperbola. I got this one. Now simplify this. If you simplify 9 t square which is equal to 6 plus 3t square by t square. When it goes to the left side, 9t power 4 which is equal to 6 plus 3t square. Right? See. Now bring it to the left side. 9t power 4 minus 3t square minus 6 which is equal to 0. Now factorize it. 9t power 4 plus 9t square minus 9t square plus 6t square minus 6 which is equal to 0. From these two take 9t square common, t square minus 1. From these two take 6 common. t square minus 1 which is equal to 0. So now t square minus 1, 9t square plus 6 which is equal to 0. Okay, equate this one equal to 0 because whichever t value you assign for this, it never be equal to 0. Hence only equate this one equal to 0. So here t square minus 1 equal to 0, then okay, t is equal to plus or minus 1. T is equal to plus or minus 1. So you got that tangent equation as y equal to x by t plus 3t. Okay, right here t value you got 1 and minus 1. If you write t equal to 1, it is going to be x plus 3. If you write t equal to minus 1 here, that common tangent equation will become y equal to minus x minus 3. You got two tangent equations. One is t1, one more is t2. Okay students, now solve both of them. You got two tangent equations. One is y equal to x plus 3, y equal to minus x minus 3. Now solve both of them. If you solve it, so we get, students tell me, so y equal to x plus 3 and y equal to minus x minus 3. Now cancel both of them. I am adding both of them. Now y equal to 0. Y equal to 0, substitute in any one of these two. If I write y equal to 0 in any one of these two, your respect to x will become minus 3. So this b coordinates you got minus 3 comma 0. You have answered to one question. What is one of the question? Find the point of intersection of these two common tangents on x-axis. You got it. And let us go to answer second question. Find the area of a quadrilateral formed by A1, A2, A3, A4. A1, A2, A3, A4. Now A1 you got 3t square, comma 6t. T value you got 1, no? If you write here t value 1, it is going to be 3 comma 6. And so t value I wrote here, t equal to 1 I wrote here, I got 3 comma 6. And here it is a vertical line. You know, A4 x coordinate will be 3 because on the vertical line x coordinate of every point is same. Hence, so x coordinate of A4 is 3, then y coordinate will be, okay, so you can write t equal to minus 1 here, then it is going to be minus 6. Otherwise t equal to plus 1 you have substituted here, you got this one. If you write t equal to minus 1 here, so this is going to be 3, this is going to be minus 6. Then you will get A4 coordinates 3 comma minus 6. Okay, right. Now go to the A2. So you know A2 coordinates you can write like this: minus a square m by c and b square by c. If y equal to mx plus c is a tangent of an ellipse x square by a square plus y square by b square equal to 1, condition is c square is equal to a square m square plus b square, but the point of contact coordinates are minus a square m by c comma b square by c. Now see here, minus a square, a value, so in the ellipse equation given as 6. What is ellipse equation? X square by 6 plus y square by 3 equal to 1. Now a square value right here 6 and m value, slope, so slope of the tangent, how much have we got? So here 1 by t, t value 1, so m value is 1, slope of the tangent 1 by t, no? So t value 1, if you write here, then it is going to be, okay, minus 6 into 1, minus 6 by c value. C value here 3. So now come here, b square value 3 and C value 3. So if you simplify this, it is going to be minus 2 comma 1. It belongs to the second quadrant. So A2 coordinates you got minus 2 comma 1. Now similarly write the A3 coordinates. Okay, so this is the image of A2. Directly you can write minus 2 comma minus 1. Otherwise take t equal to minus 1 and write the coordinates of A3. You know this ellipse is symmetrical about x-axis. So here A2 coordinates minus 2 comma 1. Then by default you can write A3 coordinates. A3 is the image of A2 with respect to x-axis. So vertical line x coordinates is same. Here minus 2 no. Directly you can write minus 2. Here image of this one in x-axis will be minus 1 you will get. So because this distance is same. It belongs to the third quadrant, hence you will get minus 2 comma minus 1. Now you got coordinates of A1, A2, A3, A4. Okay. Right. Area of that ellipse. How do you find? To find area of an ellipse, area of a quadrilateral, you have direct formula in the coordinate geometry. You can use that formula because we know here 4 vertices of that quadrilateral, then you can apply that formula. Otherwise in this figure, so you can able to find this quadrilateral area by this here, area of quadrilateral A1, A2, A3, A4, which is equal to area of this big triangle minus area of this small triangle. Area of triangle BA1, A4. BA1, A4 minus area of triangle BA2, A3. BA2, A3. Now which is equal to 1 by 2 mod of. So what is the base of this big triangle? So from here to here 6. See here ordinate y coordinate, from here to here also 6. So then base will be 1 by 2 base into height. Go to the height. So from here to here, see here 3. From here to here 3. So total this height of this triangle will be from here to here, see here x coordinate 3. From here to here minus 3, but length you have to consider as 3. 3 plus 3, 6 by minus 1 by 2. What is the area of this triangle? So here base value from here to here 1 and 1. So 1 plus 1 2. Base is 2 and go to the height part from here to here. From here to here. So minus 3. Okay, but we want this length. So subtract this 2 from this 3. So then this will be 1. So from here to here 3. From here to here 2. I want this length. Hence 2 must be subtracted from 3. It is going to be 1. Now simplify. So 2 ones are 2 6 are 6 6 are 36 minus, so cancel 1. So which is equal to 35 square units. Okay, I hope you have understood this. So one data is given between the parabola and an ellipse, and 2 questions are generated. One is find the point of intersection of 2 common tangents on x-axis. You got that? Okay. Point of intersection as minus 3 comma 0. This is the answer to the first question. And second question, area of a quadrilateral formed by the point of contacts of this tangents with parabola and ellipse A1, A2, A3, A4, whose area you got as 35 square units. Thank you one and all.